This is a pre-built version of the application. So let's go ahead and run it. And we'll have five peers that are trying to communicate. So this will be the first one. And this will be the second one. And this is the third. Number 4. And number 5. And this will be the eavesdropper peer. So here we have Alice and Bob and Carla and Dave and Elena, and this will be the eavesdropper peer. So it will pick up messages coming from all five communicating peers. And this one will pick up messages from this one, and this one will pick up messages from this one, and this one will pick up messages from this one, and this one from this one. And this one will pick up messages from this one. So Diffie-Hellman key exchange is not limited to two peers. It is possible to have any number of peers with no prior knowledge of each other to jointly establish a shared secret key over an insecure network. And P here is a prime, and alpha is a primitive root modulo P. Now suppose that Alice, Bob, Carla, Dan and Elena agree to use P equal 467 and alpha equal to 2. And for the purpose of this prototype application, I had the first user that logs in, Alice in this case, enter the value for P and alpha. So let's suppose that Alice picks 4 as her secret key, and Bob picks 5, Carla picks 6, and Dave picks 7, and Elena 8. Actually, so now all 5 communicating peer calculated this common key. So passive Eve here can see the value for P and alpha, and she can see the value of alpha to the power of A and alpha to the power of A to the power of B and alpha to the power of A to the power of B to the power of C and all of that to the power of D, but she cannot figure out the value for this to the power of E, which is a common key calculated by Elena. So here what happened is Alice took alpha to the power of her secret key and sent that value to Bob, who took that to the power of his secret key and sent that value to Carla, that took that to the power of her secret key and then sent it to Dave, that took that to the power of his secret key and then sent it to Elena, who calculated the common key. And Bob did the same thing. He took alpha to the power of his secret key and sent that to Dave. Actually sent that to Carla. So alpha to the power of B to the power of Carla's secret key, that sent that to Dave, who took that to the power of his secret key and sent that to Elena, that took that to the power of her secret key and sent it to Alice. That calculated her or the common key by taking that to the power of her secret key. And the same was done by Carla. So alpha to the power of C, and she sent it to Dave, took that to the power of his secret key and send it to Elena, that took that to the power of her secret key and send it to Alice, who took that to the power of her secret key and then send it to Bob, who took that to the power of his secret key and obtained the common key. And we have the same thing done by Dave, that took alpha to the power of his secret key, sent it to Elena, took it to the power of her secret key, sent it to Alice, took it to the power also of her secret key and sent it to Bob, that took it to the power of his secret key and sent it to Carla. That calculated the common key by taking it to the power of her secret key. And Elena did the same thing, took alpha to the power of her secret key and sent it to Alice, took it to the power of her secret key and sent it to Bob, who took it to the power of his secret key and sent it to Carla, that took it to the power of her secret key and send it to Dave, that took it to the power of his secret key and obtained the common key. So all five parties, Alice, Bob, Carla, Dave, and Elena, established a shared secret key over an insecure network, and only the secret key for each one of the peers and the common key are kept secret. Everything else is sent in the clear over the network. So you can see all those values for p and for alpha and for alpha to the power of a to the power of a to the power of p, etc. But we cannot use any combination of those to efficiently reproduce alpha to the power of a, b, c, d, e. Now much larger values would be needed here to make this example secure. And the source code for this will be available for download. Also, a longer version will be available for watching by channel members, and it will include step-by-step coding plus test running the coded application.